Welcome to the first edition of RBP Tech Talk. I am Diana Saldua, and I am with RBP Chemical Technology. So at RBP, we've spent more than 70 years developing chemistry solutions that help manufacturers improve performance, efficiency, and reliability. So through this series, we'll be talking with our expert about technologies and processes that are shaping the industries we serve. So today we're going to be discussing ONYX, which is RBP's direct metallization technology for PCB manufacturing. And joining me today is Tony Jackson, Director of Sales and Business Development for Electronics. Tony, thank you for being here.
Thank you. Glad to be here.
So before we jump into ONYX, I just want you to tell us a little bit about yourself and your background in the PCB industry.
Yeah, started back in more or less 1994 with RBP, learning and supporting our divisions that we had at that time up in our laboratory, and kind of grew myself into the market in a kind of a service position initially, and then into sales. And in sales for electronics, we all very well know it is very service related. And that has grown and grown over the years as the technology has evolved, from anything from surface preparation to DES, SES to our vast portfolio of metallization technology that we currently have, and supply and support to our customer base globally.
Perfect. Thank you. So let's just start with the basics and just tell the audience, what exactly is ONYX?
Yeah, so ONYX is a process that's utilized for seeding the whole wall for the resin and the glass in a PCB. This can be run in either a vertical mode, which is a little more rare, or in a conveyorized option, as you see here in the picture on the right. It's an alternative to electroless copper that is much more environmentally friendly, and from a process standpoint, there's much more productivity. You could get a lot more square meters or square feet out per hour in a horizontal mode. But more or less what we're doing is prepping this whole wall surface to make non-conductive areas amenable for electrolytic copper plating.
So for viewers that are not familiar with direct metallization, so what does that mean in practical terms?
Yeah, so what this process does is we clean and condition, more or less the main part is that, again, as I mentioned, the resin and the glass in the hole, and we're taking a material that is based out of a graphite type material, a very small molecular graphite, and how that's running is in the line itself we have a flood module that is more or less pushing the solution from the top and the bottom of the panel into the hole. So we are coating that panel, that whole wall, as well as the surface, to make it coated with the graphite material. And then there are subsequent steps in the process that take the graphite away from the copper surface and from the inner layer post that is in the wall, and renders and leaves that copper bare, and then keeps that resin and glass conductive.
Perfect. So here's the ONYX process, and I know the PCB industry is constantly evolving, and manufacturers are looking for ways to improve efficiency, reduce cost, and remain competitive. So can you explain a little bit about the challenges that are driving interest in technologies like ONYX, and then discuss the process with us?
Yeah, certainly. Happy to do so. Yeah, so the challenges there's some thought in the industry that the direct metallization type chemistries like ONYX, graphite based. There are some options out there that are carbon based, and carbon and graphite combined are not capable for certain geometries in PCB builds. What we've had some success doing is taking blind via work and very high aspect ratio work from customers that were running electroless copper with those jobs, and have been able to implement them into the direct metallization process. So the big key gainers to this, and with the direct metallization process, there are limitations for how high of an aspect ratio that you can process effectively. But what's key is with any process, you have a particular part that a customer is looking to manufacture, the chemistry that's being utilized, and then very, very important behind that, all of that is the equipment that the part gets processed in. So what you really gain with a process like ONYX is, as I mentioned a little earlier, much more capacity for throughput because the cycle time is much shorter than that of electroless copper. Where in electroless copper, we may have a process that is about 90 minutes to 120 minutes for the total processing with DSmear and PTH, as opposed to with the ONYX process, which mimics cleaner conditioner down to electroless copper. It's the alternative to that portion of the electroless copper. It can run down the line in about 8 minutes. So much shorter, very, very amenable and kind with regard to waste treatment. There's no heavy chelators in this process, no formaldehyde. So it's quite easy to run and control. A key step as you look at those circles is the cleaner conditioner. What we're doing there is cleaning, making sure we've got the glass conditioned. We're rinsing properly. We expose the whole wall and the surface, as I mentioned, in the conveyor as the panel goes through to the ONYX colloid. That leveler step, what that's doing is that's taking away excess graphite that is there and more or less binding or securing the graphite that is remaining on the whole wall. What is also there that is on the surface and on the inner layer post, we rinse, we dry. That kind of really dries it. If you almost think of the ONYX as like a paint, if you will. It dries it and secures it. And then in the micro etch step, what we're doing there is taking the graphite off of the panel surface and then also the inner layer post, a very important step to ensure, because if that graphite is left on that graphite post, when you go to electrolytic copper plating, you can get an interconnect defect.
That is so interesting. So it sounds like manufacturers are looking to beyond simply making boards. I mean, they're looking for an overall operational efficiency. Is that safe to say?
That's definitely agreed. Yes. And again, I'll stress here too. Customer can be wanting to look for process, let's call it productivity improvement, right? But there becomes a pinch point. If a particular customer's technology is not amenable to horizontal processing, or for that matter, there may be contracts that they have with certain customers where they can't run a graphite or a carbon-based and they have to run electroless copper. It won't work for everybody, but in our history at RBP with our technology, we have found and entertained with customers where they've been able to move some of their electroless copper processing to a direct metallization ONYX process, and it's really helped their overall workflow with the same yield and quality of deposit that they received from electroless copper. So it's a nice trade-off.
So cost savings are important, but performance and reliability are non-negotiable in PCB manufacturing. So this slide here highlights IST testing. So can you explain what we're looking at and why it matters?
Yeah, definitely. I'm happy to do so. So when we developed our technology, we knew, as Deanna said, we had to put it through its paces. We couldn't have a technology that competes with other ones that are out there, but we believe we have some significant improvements with our process knowledge and our technology and the chemistry. We had to make sure that it was robust. So this is just some data that shows how we went about our testing, and we actually used an MRT6 panel for our testing. We did this in tandem with our electroless copper as well, and it's a test panel, and we have other subsequent data. If anybody's interested, I can share that if you reach out in the future on that. But it's a test vehicle that's designed to fail. And what we did with this was subjected that test panel with our ONYX and our electroless copper, and then copper plated it with our technology, and then sent it out to an outside lab, PWB Solutions up in Canada, and they went and did this this cycling test with current to really see about the capability. And at about I think it's 350 cycles is considered a pass. loss? Well, as you can see in the second bullet point, we went to 1,000 cycles, and we did the same thing with our electroless copper as well. So far exceeded anything that was the benchmark for the industry. So what this is showing is that, the cycles we have in this distribution plot, really very, very good, robust deposit with our technology. Of course, I can't stress enough, anybody that's running our technology, RBP absolutely ensures that when we looked at that little diagram with all the little circles, from cleaner conditioner all the way to the end where an anti-tarnish gets applied, we make very sure that they have an operating process window for each one of those steps to make sure that the chemistry is being run correctly to be able to deliver this type of yield with their process.
Perfect. And this slide is just self-explanatory. So who is the ideal customer for ONYX?
Well, that's a bit of a loaded question. Every customer is a little different. So I would state this: customers that have either are 100% electroless copper today and have some opening or need for productivity gain, we'd be happy to discuss with the client any possible avenues towards consideration of a direct metallization process. So those that are looking for a productivity gain, customers that are considering green initiatives or want to be a little bit more environmentally friendly, direct metallization processes clearly do provide a greener process. As I mentioned before, no formaldehyde, no heavy chelators in the process, which makes it a lot easier on waste treatment, disposal, those types of things. So those are some of the real main areas. And as I also mentioned earlier, some customers believe that, hey, there are certain thresholds from a high aspect ratio or a blind via standpoint, they feel that they cannot process through direct metallization and they have to use electroless copper. Been able to prove to customers where we have taken the boards that they typically run through electroless copper. We run it through our direct metallization, give them all the parameters. Here's the line sequence, and then they copper plate it, and they found very, very good results. So it may take, Deanna, a little bit of time for a customer to move towards making a process change from electroless to direct metallizations. But RBP Chemical Technology, we've got some clear-cut ways to prove it with measurables and make the customers comfortable to potentially make a capital expenditure in capital equipment in the future.
So Tony, before we wrap up, so what is one thing you'd like the viewers here today to remember about ONYX?
Yeah, I would say for robustness of processing, the quality of the deposit with ONYX matches anything that is put down by an electroless copper, whether it's RBPs or competitors. With that, if a change is made, it would definitely give the customer an opportunity to increase throughput with the same level of reliability. And also lowering your overall operating cost compared to electroless copper.
All right, Tony, thank you for joining us today and sharing your expertise. And thank you to everyone who is watching our first RBP Tech Talk. So if you'd like to learn more about ONYX direct metallization or discuss how it could fit into your PCB manufacturing process, please go on to rbpchemical.com or contact someone on our electronics team as well. And those numbers and contact information is all on our website. Thanks again, Tony.
Thank you, dear.